Hello everyone, in this video we are going to solve problem 38 of chapter 4. Determine the moment of the force F about the door hinge at A. Express the result as a Cartesian vector. So we know moment can be determined by R cross F. That's the equation. So R would be the position vector. We want to find a moment about A. So our position vector would begin from A and go through C, so that would be RAC, because we want to find a moment about point A. Our force, we have the magnitude 80 pounds, but we don't have it in Cartesian form. The equation forces us to use the Cartesian form. So we need to find a position vector from A to C. We have the coordinates, so it should be easy to find the position vector. And then we need to find a force F in Cartesian form. So if we have the magnitude of force F, the Cartesian form would be only multiplying by the unit vector. So which unit vector? The direction of the force F. The force F is towards, from C towards D. So UCD. So I need to find UCD, the unit vector from C to D, and also the position vector A to C. UCD, the unit vector from C to D, would be the position vector divided by its magnitude. From C to D. So I write it here. That would mean we are going for negative 5i plus, here we have 3 plus 2 square root of 2 because of the angle 45 here, and then this is 4. So if we are going towards, this is 3 plus 4 times a square root of 2 over 2. So that gives us 3 plus 2 square root of 2j. And negative 2 square root of 2k from C to D. So I'm going down here, and that's 4 sine of 45. And the magnitude would be, if you find a magnitude, would be 8.183. So UCD would be negative 0.611i plus 0.711j negative 0.345k. Now I have UCD, I can find force F. This is a vector, this is a scalar, so I just multiply each component by 80, and that would be my force F. So negative 48.88i plus 56.88j negative 27.6k. The unit here is pound. So I found my force F. The next thing I need to find is the position vector AC. So RAC, position vector from A to C, would be 6.5i negative 2 square root of 2j plus 2 square root of 2k. The unit system that I deal with here is feet. So I have the two vectors that I needed, so I can find the moment about point A. Would be RAC. So I'm writing the equation here after we found the two vectors. IJK. That's the first row. The second row would be our position vector because that's the first vector here. So I just write 6.5 negative 2 square root of 2, 2 square root of 2. The third row would be our force. So negative 48.88, 56.88, negative 27.6. And I'm going to write the result here. The moment A, negative 82.9 I plus 41.5 J plus 232 K. And the unit that I have here is pound foot. So the only difference of this problem to the previous problem that we solved is that force F is not given to us in Cartesian form. So we have to find it in Cartesian form. We have to multiply it by its unit vector. And the other point is that the direction of the position vector is important. If we want to find it about point A, it means the position vector begins from A and goes to where our force is being applied to.